Okay, it's the top of the hour. I think we should get started. Welcome everyone to this session of the DETNET Working Group at IETF 125 in Shenzhen and remote. We chair this group together with Lou Berger. I'm János Farkas. And we have our secretary, Yves Schuler, at this meeting as well. And we would like to thank to Carlos Bernardos and G. Dong for facilitating running this session on site. You can find the meeting material at the usual place. And at the first place, I would like to remind you the IETF Notewell. This is a reminder of some of the IEEE policies. For the details, please check the links and RFCs here. And most of all, by participating the IETF, you agree to follow the IETF policies and procedures. And participants are expected to behave in a professional manner and courtesy to colleagues. I would like to remind you that all the contributions, verbal and written contributions, become part of our permanent records. This session is being recorded as well. And if any of these things are not okay with you, then please cease participation. I would like to remind you again of the conduct guidelines to respect colleagues and behave in a courtesy manner. And for the meeting participation, the logistics on-site, please join the on-site tool. This is important for the virtual blue sheets. And remote, as usual, please be muted when you are not speaking. And please join the note-taking. This is a joint note-taking. You can find the link on the slide in the chat and the meeting materials and other logistics at the usual place. I would like to highlight that we have a very tight agenda. The times listed on the agenda include discussion times. We have a few recently adopted documents. The discussions are limited to the issues or that we should focus on these documents, and a few other documents we will hear during this session. As for some of these contributions, we plan to have a polls, and we plan to ask two questions. First, what do you think? Is it interesting for the working group to start working on a topic? The other question is it the current document suitable foundation to kick off the working group work? Reminder that for the working group documents, the authors, presenters, please focus on the changes and the issues happening from the last meeting. And for non-working group documents, please focus on what do you suggest to address with your contribution. Working group status. Good news that we have one new RFC. This is the DETNET control airplane. Many thanks for all the contributions. And also two more in the queue. The raw technologies and the raw architecture are coming up pretty soon. So stay tuned for that. We don't have anything at working group last call, but we have a bunch of queuing solutions recently adopted. And as we asked in email as well, please capture the raised issues during the adoption call. There are some outstanding issues, work to be done, and so on with these recently adopted documents. We have a couple of documents that are not on the agenda. And I would like to mention the one in the bottom of the list, which has no update for a year now. And we're planning to move it to that state if it is not picked up. It's always possible to pick it up. Few words on liaisons. We have received one for information liaison from ITUT Study Group 13 on the work conducted there on deterministic networking related items, recent publications and results. And as one of our queuing solutions is based on recommendations published there by ITUT Study Group 13. You will see more details during the presentation. We expect to potentially send a liaison letter from our side to them to inform the work in progress status. And I would like to remind you the IPR policies as well. So please follow the IPR policies. We ask about it during adoption call and when moving to working group plus call as well. And it is the mailing list, the main for us to progress our work. So please use the mailing list. The consensus is determined in the mailing list for all subjects, and we have good technical discussions on the list. So please keep that up and continue, especially for the newly adopted documents, which is just a start for the work. We can have virtual meetings interims if and as needed, or we can also schedule informal meetings. Please let us know if you see the need for such meetings and we set it up. And as a reminder, we keep asking about document status. So please do that. And we have not received status updates for some of the documents despite of the request. Anything to add from your side, Luan?
Just we have Jinu in queue.
Please, Jinu.
Hello, chairs.
Hi.
In your presentation, the stateless fair queuing document is listed as the adopted draft, but I'm not sure about it. So please make clear about it. Thank you.
You mean the first one here on the list, right?
Maybe the last one, draft JOUNG, then stateless fair queuing.
Yeah, so the situation is that it's adopted, but we are trying to clarify all these relationships with ITUT to be totally on the clear side on the relation, and this draft should provide what's augmented to the ITUT recommendation, and once that is clarified, we would like to ask you to make the document as usual draft IETF DETNET. So make the next step and make it in a working group document.
Okay, thank you very much.
Okay, no further questions, comments. Let's move on to the first presentation, which is Gino with the taxonomy.
Hello, everyone.
Hi, the audio works fine, so please proceed.
Wait, Carlos, are you handling the slide switch?
I know it.
I can potentially change. Do you want me to change?
This is what I did. Oh. Okay, that then. Yeah, the first one. That one.
Yeah, that's it. Thank you, Carlos. Hello, everyone. I'm Jinu Jang for the presentation of the taxonomy draft. Because we don't have much time, I will just read through the presentation material. So if you have a question, please raise the question after the brief summarization of the slides. So this is the overview of the draft. It is to facilitate the understanding of the data plane enhancement solutions. It has defined a few criteria. One of them is based on the performance, and 4 of them based on the functional things. It also specifies 2 reference topologies. It has specified 7 suitable categories that the adopted solution is based upon. So the change in this version 5, is the addition of the section 8, which is titled as Considerations for Interoperability Between Solutions. So what is the interoperability? It is defined between technology domains. I will call it TD. How well solutions can operate without special treatments. TD is defined as a contiguous segment of a network where all constituent nodes share a common data plane solution. So how can we measure how well the solution can interoperate with each other? The authors have come up with two metrics. The first one is called gateway complexity, GC. It is about how difficult and complex it is to combine two different TDs to make them work as intended. Okay. The second metric is so-called performance preservation level. How easily the requested end-to-end service level can be met throughout the end-to-end path in the multiple TDs. So these two metrics are raised in the draft, but as you can see, it is kind of compromise in between. If the gateway complexity is high, the PPL is very good, and vice versa. So it's kind of complex situation. So the gateway complexity involves both control plane and data plane. For example, in control plane, end-to-end admission control is a serious issue. And another thing is the cross-domain network configuration. For example, slot length negotiation. Okay, the slot length can be long enough. It should be long enough to accommodate all the traffic generated during the slot. This may be kind of confucius to you. So if I clarify in more clear term, so the slot length has to long enough for the maximum possible traffic generate during the slot length. Okay, so this can be kind of obvious to some of you, but maybe not to the others. This is not a trivial issue to decide the slot length, because longer slots lead to more traffic. If you are interested, you can refer to the reference 1, which is specified at the end of the slide. The another part is data plane. The metadata involved in the solution has to be translated, inserted, and maybe deleted if possible. And another thing is flow reshaping. And the third one we can think of is flow aggregation and de-aggregation. So let's consider a little bit further about the flow reshaping. Okay, flow reshaping can be critical for interoperability. If flow is reshaped or damped perfectly, then a TD can be operated as if it were an isolated system, right? However, flow reshaping may require per flow state maintenance, which can be very complex in a large scale network, and packet damping as well as reshaping may be impossible when multiple packets or multiple flow contend for the same egress interface. So the basic idea is that shaping and damping is not the solution for scheduling. It is a subsidiary or complementary solution for the scheduling itself. Another example can be the interleaved regulator defined in TSN standard. It reduces the complexity by having only one per flow queue. The only one queue, not per flow queue, but it is not free in terms of the latency bound. What is the fact is that the maximum bound of FIFO system cascaded with IR remains the same, not the flow's maximum bound. You have to keep that in mind. So as you can see, the intermixing, interoperating these two TDs can be very complicated in many ways. Another aspect, another metric we can think of is the PPL, performance preservation level, the solutions of certain categories can be beneficial. Solutions of other categories is not. Okay, so it can be considered in very technical way. And how to measure PPL over domains is still under study. As I have said in the beginning of the talk, it can be a design choice for the balance between GC and PPL. So it is still under study. So this is the example interoperability level table that we have, the authors have made so far. So in the x-axis and y-axis, there are suitable categories, which can be as many as 7 for now. So we can have a combination of these 7 by 7, maybe 6 by 6, because the same category can be neglected. 6 by 6, that is about 36 possible combination of the metric result. So this is for further study, and if you have some idea or suggestion, please let us know. The future plan is to elaborate section 8, which I think is the last section, I mean the last part of the draft that we have to elaborate. And after section 8 stabilizes, then I think the document is almost done. Thank you. If you have any question, please. Okay, then let's move to the next slide.
Yeah.
Yeah, the next slide is slightly longer, but I tried to cut it into 8 minutes.
Since we lost one presentation, you actually have 9.
Okay. I'll move to the second slide, latency guaranteed stateless fair queuing, so-called C-score. It is now 8th version. Overview, what happened after IETF 1 to 4? There were 3 revisions, 6, 7, and 8. So in revision 6, some of the subsections and sections are added. The most prominent ones are 6.3.2, 6.3.3, and 7. So they are about header format, admission control, and finally, the approximation of the C-score. I will elaborate each of them one by one. Oh, and one more thing I have to say about the revision is that the revision 7 and 8, we have tried to minimize the duplicative parts with the ITUT standards. We added relevant references and added a section that describes the relationship to those ITUT standards. So basically, one important thing about the revision 8 is it is currently a complete document. It means it is readable by itself. So if you read the revision 8, then you understand the whole idea. Okay, that's one thing I have to mention at this point. So from now on, I will speed up a little bit. This is the header format defined in subsection 6.3.2. The first IPv6 based header format is given here. I will not go into the detail, but if you take a look, you will just understand. It is recommended to use the hop by hop options header, which is designed to be examined and processed by all the transit nodes, okay? And there are, in the figure 1, there are 2 exemplary metadata. The first one is the L divided by R, and the second one is the finish time, FT. This is a little bit obvious, but the second one is maybe not, which uses MPLS post-stack MNA. MNA is the network, MPLS network action. So in this, so there can be 2 options. There can be 2 possibilities. One is the in-stack MNA. The second one is the post-stack MNA. In-stack MNA is within the label stack. Post-stack MNA is outside. Okay, it's that simple. But in this draft, we recommend post-stack M&A sub-stack, but the in-stack M&A is not excluded. So you can use both maybe at the end of the draft. But currently, this is the suggested as an example. I would not go into the detail as well. All the header fields, they are complicated, but if you understand, they are not that difficult to understand. Okay. So this was the subsection 6.3.2. This is subsection 6.3.3, automation control process. In short, subsection 6.3.3 suggests two different automation control process. The first one is the default process, which is quite obvious and based on the well-known RSPF, that the entrance node or the source requests the service rate explicitly. And if that is acceptable, then the flow is submitted. This is all we know. The second one is the alternative process, which is a little bit complicated. The source or the entrance node requests specify two different rates. One is the desired rate, and the other is acceptable rate. So desired rate is a higher one, and minimum acceptable rate is the minimum service rate the source can tolerate. And in the process of the automation process, the core nodes decide the path available rate based on the minimum operation. And finally, at the destination or egress node, or whatever you call it, decide the optimal service rate, which is in between the desired rate and acceptable rate. So there are two possibilities. Using the alternative process can be beneficial if the flow, in the sense that the flow can allocate it better and network acceptable rate. So lower end-to-end latency can be expected. This is the section 7, approximate Z-score. This is kind of technical, but I will try to explain as brief as possible. If you look at the figure on the right side, there are multiple queues, but they are basically strict priority scheduler, so-called SP scheduler, which is used worldwide. Everybody uses it. Every router uses it, okay? So it's a very simple and deployable. One thing different from traditional strict priority scheduler and approximate Z-score is that the priority rotates at a fixed times periodically. Periodically, the priority shift. So if the Q1 has the highest price, Qn has the lowest price priority. But if Q2 has the highest price priority, then Q1 has the lowest one. But that rule doesn't change up until the end. Okay, and if the arriving packet has some finish time, and according to that finish time, the packet is assigned to a certain queue. So finish time decides the allocated queue. So it is a rotating priority scheduler with finish time based allocation. By doing that, we can guarantee the end-to-end latency bound, specified as theorem 3. With that inequality.
Sorry, do you want to take, because there are people in the queue?
No, I'm going to interrupt, actually. I'm sorry to interrupt.
Okay, so there are some people.
We only have a couple of minutes. We only have a couple of minutes left, and we haven't addressed.
I'll finish.
No, excuse me. I'm sorry to be rude, but we need to go back to the first slide and make sure we cover the topic that we asked to be covered in this slot. In the first slide you talked about. In the first slide you talked, or second slide, you talked about. I'm sorry. One more. You talked about that you've made changes to address the ITU section, the ITU relationship. We mentioned earlier in the session that we need this clarified in order to complete the adoption process and get it published as a working group document. There was some discussion on the list that seemed to, at least my reading of it, is that there's another version needed before we can publish. Can you tell us your plan for that?
Okay, yeah, the plan is at the very last page. I'll just skip every page. I will go to the this slide. Yeah.
Thank you.
So future plan is that any duplicative parts will be removed, and only a couple of sentences or a paragraph regarding the philosophy or the principle of the stated fair queuing will remain. By only referring the existing IETF standards, right? The existing IETF standard describes the framework and requirements. There are duplicative parts still in our draft, and many people or some of people wants to remove them completely. So I try to follow that suggestion. Yeah. So that's the revision plan. One more revision is necessary, I think.
Thank you. We'll work with you online to make sure that that's acceptable, and then we'll get the draft published as with draft IETF. That really needs to be the focus at this point, is getting that draft into full working group status. Thank you so much for the presentation. G, if you don't mind switching to the next one, because we're out of time. And while we're doing that, Mike, you can ask your question, and then Janu, you'll have to respond on list, please.
Okay.
Because we're really out of time. Okay. Thank you.
Thanks, Lou, and thanks, Jinu. And yeah, thank you for proposing this update, and removing the duplicative parts of the draft is good. I do still have a concern that the proposed header metadata structure proposed here, it conflicts with the existing ITU standards. We can follow up offline, but if the ITU standards are inefficient or incorrect, they should be updated. We should not create an incompatible standard.
Yeah, thank you for the suggestion. What I'm planning to do about the ITUT standard is I will update the curriculum and try to harmonize with the IETF draft. Okay, if that is acceptable to you and Scott.
Let's take that discussion. Let's take it to the list, and we'll need to make sure to have confirmation there. Kwan, I'm sorry, you'll need to move to the next presentation unless Janu wants to take more of his time, because he's already eating into his time for the next for this presentation. And Janu, I really ask you to stick to issues raised and the plan to resolve them.
Okay,
thank you.
Thank you. Thank you very much for the suggestions.
Janu, I think I apologize to Yunshil. We took some of his time here. Who's presenting? I know you're an author on this one.
Yeah, Yunchul is presenting for the N-score.
Yeah, so sorry about that. We actually ate into his time. We'll give you a little time back, but sorry about that.
Hi everyone, my name is Yunchul Liu from Metri. This time I presented a non-work conserving stateless core-fair queuing called the N-score. This draft was adapted as a working group draft through the adaptation for before this meeting, and it has updated to the version 1 to address the comment during the adoption for goal of this draft is the provide a latency-based bounded end-to-end latency and jitter. It ensures the packet are bounded within the application specified latency range through the approach priority rate allocation. Taxonomy of this solution is the flow level and rate-based left-bounded category. The version 1 update mainly addressed the errata and reference updates based on the comments during the adoption poll. Thank you for your comment, Andrea Francini and Zhongfeng Du. First is the editorial error fixed, and second is this description clarification, because the previous version simply described the packet stored in ascending order of the eligible time and finish time. This part which lead to the misunderstanding. So therefore, I in this version clarify the description as the packet packet as packet are first push it into the temporary queue with the ascending order of the ET, and upon their eligible time, the packet transfer the service queue and push it with the ascending order of the finish time over the packet serviced after the eligible times in order of the finish times. This make it non-work conserving schedule. Third is the reference to the syscore and taxonomy part added. Currently, this draft is no issue remaining now, and N-score and C-score solution are planned to the implemented on the implementation for the FPGA. We already have completed the software design and currently coding for the implementation of the N-score and C-score both function using the FPGA. Thank you.
Thank you. I'm so open from ZT. I have a question is that you implement the N-score, so that if a packet arrived at a downstream node, you have to dampen the bucket to holding some time, so that you will remove the JIT. Okay. So I wanted to know the implementation details or the design details about how to design this damping buffer. It is calculated by, for example, it dependent on, sorry, is it related with some classes, or it is just stateness someone? Maybe you can give some clarification in the next version about the design details. Thank you.
Okay.
Thank you, Xiaopu. As a co-author, if I can answer you briefly, the N-score is similar to C-score. It doesn't have per flow state maintenance mechanism, so it is scalable. And similarly to C-score, it calculates the finish time at the very beginning of the flow, at the entrance node, and in the subsequent node, so-called core nodes, do not need to maintain any per flow state. Only difference between C-score and N-score is that N-score is non-work conserving or left time bounded. Okay, thank you.
Next is the on-time forwarding with the pushing first out queue. This is also adapted working group before this meeting, and it also updated to the version 1 to address the comment during the adoption poll. And goal of this draft is guarantee application specify the minimum and maximum end-to-end latency. It scheduled the packet to meet the specified latency targets. And taxonomy the draft of this solution is a flow level non-periodic bounded category. The version 1 update is mainly address the error time reference update based comment. Thank you for your comments, Zhongfeng Do again. First is editorial error fixed, and second is the figure description clarification, because previous version is simply described. So in this version, updated more detail. And third is a reference to the taxonomy is added. This draft have a issue from the Xiaofeng. Thank you for your comment. Issue is how to guarantee the packet scheduling before the maximum departure time, and can you please edit the mathematical formula and further illustration based on the reference topology in future version? This issue, as mentioned, the draft, the maximum departure time is determined by the node delay upper bound from the arrival time, and the admission control verifies that the difference between the node delay upper and low bound can provide the sufficient time to process all packets. So in the future version, we plan to add the mathematical formula for the more detailed explain regarding admission control part. Thank you.
Any questions? Okay, we'll move on to the next. I think it's Peng or Shafu, sorry.
Pony from China Mobile. So it's about the deadline-based forwarding solutions. Thank you. So this is just a really briefly overview of the updates about the status. So it was just adopted by the working group as a 0.0 version draft. So here's the open issues during the adoption call. So first is that add the definition of the abbreviation such as earliest deadline first, and the authors plan to solve this as a suggestion. And another is that clarify that solution scope, whether covering option 1 to 4 or just option 3 and 4. So the option 1 and 2 is stateless, and the option 3 and 4 is stateless. So the authors designed to delete the option 1 and 2 to maintain the scalability of the solutions about it. So the next step is that we will address the issues in the next version and focus on the optimal solutions. So any question or comments on this?
Thank you for the update and sticking to the request. Appreciate it.
Okay, thank you.
If there are no questions, we'll move on.
Okay, sure. It's about the time slots, queuing, and forwarding. This one is also just adopted by the working group as a 0.0 version. And here are some open issues during the adoption call. So first, we add a section operationally consideration to describe how to apply the TQF mechanisms in the overall network. And second one is puts section evaluations into the appendix part. And the third one is polish the text and revise the minor errors about it. So for the 3 points, the authors decide to revise the document according to the suggestions. And there's also a suggestion from the chairs. There are more similarities between TQF and TCQF, and better to merge them. This hasn't been addressed because the authors of the 2 drafts have not find the right way to really merge them, and it might need more discussion on it. And the another is about the questions on the end-to-end delay bound of this solution. Is it the sum of the each offset plus to the slot length, or it's SPL of it? So the authors confirmed that the formula is a formal one. Is that for each flows there will be a pre calculation on it, and in each node there will be a fixable offset. So so the delay will be the formal one, and the authors has replied in the mailing list. So the next step for this draft is to try to address the to merge the 2 drafts, but need more discussion on it. And I see someone in the queue, Janos.
Yes, thank you for taking this up and actually bringing the commonalities up in the list, and thank you for taking the initiative. I hope the discussion goes on, because I think it would be very beneficial for the working group if the 2 solutions could be merged, and kind of my take was from the discussion on the list that one of them is a kind of a subcase of the other. But I see a queue building up. I think Gino is next, and then Torres, please use the queuing tool as
Sorry,
well.
Torres. Yeah, I have the. Could you go back to the page 3? Yeah, I am the commenter on the last bullet about the end-to-end delay bound. Yeah, also, although we have exchanged some emails, but we are still struggling to find out which one is the right one. Okay, that's the one thing I have to mention. Now, another thing is that if the first expression is correct, then I think TQF and TCQF are still completely different with each other. One is the flow-based, one is class-based. Class-based is scalable. But if you insist that TQF is flow-based, I'm not so sure it is scalable because we do not usually, for scalability, schedule flows for each slot per each hole. I think it is too complex. That's my suggestion. Thank you.
Okay, thank you. Maybe Shaf, you may want to reply this comment.
Thank you, Gino, for the question. Yes, I think it is reasonable to think that the T-curve may looks like a class-based mechanism. However, I think we can, for each flow, we can allocate the specific time slot stack, all the time slot seedlist for this flow. So I think each flow is well protected by the assigned slot queue. So I think it's also a flow-based mechanism. And anyway, for multiple flows, we can assign a dedicated slot on each node for multiple flows. So that means multiple flows can share the same slot stack. So in this sense, it may also looks like a class-based mechanism. So, but I think the main feature is flow-based.
Thank you. I think this is an important point and we should continue on the list. And I would like to recognize Torles, please. Torles, go.
I've already tried to explain this a few times, and that's why I've written the flow interleave draft, which is also a reference from TCQF and from GLBF. In TCQF, the number of cycles and the time for these cycles is very much limited to only what is necessary to overcome a link's latency, so that we can basically deal with the variation in link latency independent of how many flows we want to multiplex. That keeps it very simple. We have high-speed hardware implementation and independent of the total number of flows. It does not solve the problem that if you have 1 million flows, each of them just sending 1 packet per second, or let's say per 100 millisecond, we want to interleave them in a way that they're nicely stretched out over the 100 millisecond. So what we're doing is we have this long set of cycles, so to speak, for the flow interleaving at the ingress of the network. That's what flow interleaving does. We don't do it hop by hop, but if you need that flow interleaving, you put it on the edge of the network as an ingress function, like we have others like aggregation or so on, right? And in TQF, you have this function effectively on every hop. That's what makes it per flow, because for every flow, you're now per hop doing that stuff, right? So that's why I think they're fundamentally different. And that's why, you know, for example, to achieve the same thing that TQF does flow-based, we need kind of 2 layers. We have a very simple TCQF layer throughout the network, and the flow interleaving happens on the edge.
Yes, we
Shafur?
have some more discussion the merits to distinguish the difference of these 2 mechanisms. Yes, I think TCQF has the fixed time slot offset. So I think it has scalability issues that it just can support a limited number of flows, because all these flows want to send before, for example, 1 slot offset, but there are so many flows and the link speed is limited. So the must have some flows cannot be sent as soon as possible. I think this is the difference. I do think it is a special case of TQF. So maybe we can add some more clarification in the next version to illustrate how this special case is work in TQF. Thank you.
Okay, well, we may need more. Okay.
Yeah, usually from Huawei. Personally, I would prefer to make them as separate documents, so there is no free lunch. So for TCQF, the advantage of it is simple. So including the configurations. So if we consider like a one size fits all solution, then we want to degrade it to some kind of simple solution. What happened with all the configurations and provisioning kind of a thing? If it's naturally by natively, it is a simple solution, then the configuration and, and provisioning considerations are all very straightforward. So I don't think the downgrades in some way or with some twist of the TQF make it looks like TCQF is a good way to merge them.
Torles, please go ahead. Torles, please.
Yeah, I think the other part, just to re-emphasize on this, the flow interleaving we can do on the edge. I didn't put that in the TCQF draft, which we could do. I mean, I first need to catch up with the. I didn't manage to do a new version for this IETF. I apologize. There was too much after January, so I'll be back to it shortly. But once I'm catched up, I'll bring up the question of what we do with the flow interleaving, because this edge function on ingress for flow interleaving is not only applicable to TCQF, but it would equally be applicable to GLBF, right? Anything forwarding wise that is quasi-synchronous, as both of these are, right? One with cycles, the other one without cycles, but it can be applied to that, which is one, I think, of the reasons why it should stay a separate edge function and not be, integrated into TCQF.
Gino, please.
Yeah, I will make it quick. I would like to suggest Xiaofu to demonstrate an advantageous scenario by having a flow-based slot allocation. Okay, so CQF, if you think of the CQF and eCQF proposed in the 802.1 TSN, so even the class-based solution can differentiate the end-to-end latencies of flows. Okay, so personally, I think the class-based solution is enough. But if you come up with the scenario, operation scenario, the flow-based solution is much more efficient and differentiate as many flows as possible, other than more than eCQF, then I would be greatly appreciated. Thank you.
Yeah, so I would also rephrase it to say that TQF, I don't think, meets the requirement for these large, high-speed, large-scale networks that we set out initially, right? On the other hand, as Jinu said, it very nicely reflects what already TSN can do with its solution. And having talked with some of the TSN folks, there are in-factory floors, non-scalable requirements where you have strange latencies where you need to buffer on an intermediate hop or so. So there may be good use cases for that, and we become less, dependable on applying TSN technologies. But people could, in a factory floor, directly use TQF for that, right? So I don't think it's part of the fast, large-scale things that we set out, but as far as, we already do a lot of different forwarding mechanisms to become standalone so that people don't have to inherit TSN, and in that scope, I think it's a good fit.
Okay, I think there's several issues proposed just now. So we think that, so first, this had been adopted, and when we discuss about the merge, I think that the author of the TQF don't think it should be merged. Personally, I also agree with some points with Torres and Ijo, but I think not all the authors of the two draft has the same idea. So we may need more discussions on it, and to get the consensus among the authors first, and then to report to the chairs to decide whether deal with it. And the second point is that about the scalability of this draft, just simply reply, it's not on the pure flow-based solutions. It's it is a solution maybe between the flow-based and the class-based. So this also need more clarification on it. Maybe we need to address these two aspects of the questions. So I see the chairs in the queue.
I actually was appreciating your summary, so please can finish your summary, and then I can make the comment.
Yes, I just done of the summary. I think there are two main points of the authors need to do after the meeting. Yeah.
Yeah, thank you for a very good discussion, and I really appreciate your summary at the end, and it makes a lot of sense to me. While looking at it and discussing it among the authors, please consider the difference between queuing mechanism and classification mechanism. The discussion here, the disagreement seems to be on classification, how you identify what packets go into what slot, not so much on the queuing mechanism. I suspect there might be some differences there, but maybe that's where we can reach alignment. So can you consider both of those in the discussion? Thank you.
Okay, so the queue is empty. Maybe we can move on to the next presentation.
Thank you.
Thank you very much for a good discussion and presentation.
Hello, everyone. I'm Chuan Sheng from ZTT. My topic today is flow aggregation for enhanced DETNET. This has been presented for 3 times, and thank you for the comments and suggestions in the mailing list and at the meeting. And so based on the comments, we update the version from 3 to the 4th. We revised the objectives and the requirements for flow aggregation in enhanced DETNET. We clarified the multi-domain requirements for aggregated flows. We also added Carlos as a co-author, and thanks for his contribution. And this is the structure change for this version. So let's quick recap the modification. For enhanced DETNET data plane, the scaling requirements ID has proposed the data plane requirements, and it should support the explicit aggregated flow identification and provide aggregated flows over multiple domains. So with the different levels of SLA requirements. And for multi-domain DETNET control plane, we also have a new ID, the multi-domain framework, to discuss the consideration to achieve the end-to-end queues guarantees for aggregated flows and to across the multi-domain. So this document mainly describes the requirements and the enhancements for flow aggregation in both data plane and control plane in the scaling networks. So we provide some 3 requirements and the scenarios for flow aggregation in scaling networks. The first one is aggregated flows across multi-domains. Flow aggregation in the multi-domain scenario must achieve the end-to-end queues guarantee, and the aggregated flows may span across multiple domains. So the flow aggregation should be identified, and there's some information should be exchanged in the control plane. And the second one is that aggregated flows with fine-grained queues provisioning. The scaling requirement ID has specified the scalable flows are coexisted, and the different levels of applications differ in the SLA requirements. So the DETNET flows with the same level of the surface requirements can be aggregated to receive the collective treatment. So the maybe we need to define some predefined classes before the aggregation. Finally, the aggregated flows with burst flows across multiple hops. The flow aggregation will be frequent with dynamic drawing and living in scaling networks. So it may potentially lead to the accumulated bursts of flows across the multiple hops. So that the DETNET flows should be aggregated with the correlating packets with the aggregate within the aggregated flows in data plane. So we also provide the enhancement consideration for flow aggregation. First one is the flow classification. The data flows may be classified into several predefined levels based on the service SOA requirements. And the service should be provisioned on an aggregated class level rather than the flow level. So a second one is a flow identification. It may be dynamically identified the aggregated flow. So it may be identified by aggregation ID or the aggregated class level. For example, there are several predefined classes. So the encoding of the aggregated flow information may be encapsulated with the aggregation-based metadata we will discuss in next presentation. The next one is the flow correlation. In the control plane now can need to advise advertise the interdomain resources and the queues correlation information for the aggregated flows, and the burst of aggregated flows could be mitigated by correlating the packets within aggregated flows. So this is the enhancement consideration for the flow aggregation. So we have the authors think that it is stable for all the flow aggregations requirements and the enhancement. So the authors would like to know, is it a useful work for working group adoption? Thanks.
Torles, please go ahead.
I'm still struggling a little bit where to position this, right? Because I think it's very high level and ultimately it may be useful framework, but I'm starting from the low level and thinking about if I want to do aggregation on the edge of the network on Ingress, the way I need to think about this differs by the forwarding algorithm I'm using, right? So I can do aggregation with the interleaving for TCQF and GLBF. But if I was looking into a GNU C-score, for example, I would guess that the calculation would be quite different, right? So, for example, I'm not quite sure what flow aggregation exactly would mean for GNO's forwarding mechanism, right? So, and if we ultimately have a document that describes that for all the different forwarding schemes, or if we ask each forwarding scheme to basically say, here are the things you can or cannot do for aggregation on the Ingress side, I think that's where I'm starting from. And then whatever we come up in that point, if we agree that everything about aggregation should be put into a separate common document, maybe this is a starting point. But in the first place, I'd rather like to understand what each of the forwarding mechanisms think about what it means for admission control, for example, right? For the calculation of, what is the aggregated flow? What can you specifically do? I mean, I have this for TCQF and GLBF. I don't know for the others, right? So once I understand that, I'd have more opinions.
Yeah, thank you, Thomas. Yes, you're right. This is the start point for flow aggregation. It is informational draft. Our motivation is mainly summarize the data plane and the control plane requirements, and to provide some consideration for the enhancement, including you mentioned the different data planes, different queuing solutions may have different flow aggregation, correlation, or interleaving, such as these solutions. I think we may clarify it in further versions.
Balazs, please.
Thank you for the presentation. I have two comments or questions. The first one is a general clarification question. I think that in the data plane, in all the data plane documents, we have already we have already described how to aggregate flows. There are specific formats for flow aggregation already described. And you said that this is a informational document which is just describing requirements. So my question would be whether those aggregation methods defined for the DETNET data planes, is there something wrong with them? Do you have some additional requirements and you would like to modify it? Or what is the relationship to the already defined aggregation format?
Thank you. In data plane, as we just discussed, we think there may be some correlation and interleaving solutions, and different queuing mechanisms may have different data planes solution extension for flow aggregation. So we may provide the requirements for flow aggregation, especially in data plane. And so maybe the detailed extension or detailed enhancement are within the each queuing solution. So we in this document, we just provide the requirements scenarios and the enhancement consideration.
Okay, my statement would be that these requirements are already covered with the existing documents, but let's discuss the details. I have also a specific question on slide 4 on flow identification. This is also something, but the work group already spent some time to define how flow identification is done in DETNET. Are you proposing new methods for flow identification? Because this additional metadata that is somewhat disturbing for me. That looks like there is something wrong with the existing flow identification methods, and it is not clear what you are arguing for. What is wrong with that?
Yeah, thank you. We will add some clarification. Thanks.
Okay.
Thank you for the presentation and the discussion. You asked about adoption. We, as chairs, had discussed this and actually was almost talking about Balazs's point completely independently. So a couple of comments. Number one, I think Torlis's observation that this is a bit of a framework is accurate, particularly because it doesn't go into all the details on the queuing. So that would be great to add that to the title and also add it to the intro of the document, that this is a framework for aggregation as opposed to a specification. So that's one good adjustment that we would need before considering adoption. The other one is, and this is a bit aligned with Balazs's point, is we really need to discuss the relationship with the existing data plane formats. So this isn't queuing. This is the packet formats and how the different DETNET data plane formats are supported in this aggregation framework. And as Balazs commented, there's a lot to build on, but we really need to cover the data plane formats that we have before saying that this is something that's really covers the working group's scope. Thank you. Torlis?
So yeah, that wasn't clear to me if it even makes sense to purely constrain to just the encapsulation part as opposed to the shaping timing part, right? Which very often is going to be part of what happens on ingress. So that would be good to be very clear about what we actually want to do here.
Yeah. Okay, thank you.
I think the discussion reflects for me that it's too early for adoption pool. So I would suggest to consider the feedback you received.
Yeah, I think we can move to we can move to the next one. Thank you again.
Thank you. Hello, everyone. Next presentation topic is the data fields for DETNET enhanced data plane. So since we have adopted 7 queuing solutions, so the authors may think that it's a good time to consider the queuing-based metadata. So this document defined the metadata and the common data fields for the DETNET enhanced data plane or data plane, their solutions or queuing solutions to support their for example, the deterministic latency and the aggregated flow identification. This version has updated. For example, we aligned with the suitable categories as defined in the data plane taxonomy. We revised the deterministic latency metadata to align with the adopted 7 queuing solutions. We also discussed the option of the encoding for DETNET enhanced data plane metadata. For example, the reuse of the existing DSCP or the encapsulation in IPv6, SRv6, and MPLS networks. We also add Gino as co-author, and thanks for the suggestions. So for the deterministic latency option, it may carry the queuing-based metadata. We defined the 7 categories, 7 types for to align with the suitable categories. The deterministic latency information should be carried for forwarding nodes along the path which can apply the corresponding queuing mechanism and the related information in the packet to achieve the end-to-end banded latency. So we defined 7 types and the corresponding information. First one is in the right banded category, and an example is the EDF queuing mechanism. For this type, it must carry the maximum time bound. And for the second one, flow level periodical banded category, the example is the TQF queuing mechanism. It must carry a set of time slot. So we carry the time slot ID in this type of information. And the third one is the class level periodic banded category. So the example is the TCQF, and we carry the cycle ID in this type. The fourth one is the flow level non-periodic banded category, and the example is the PIFO queuing mechanism, and we may carry the maximum time bound and the minimum time bound. And for the fifth one is the class level non-periodic banded category. It may carry the example is the LGBF, and we may also carry the minimum and maximum bound. And for the sixth one is the flow level rate-based unbounded category. The example is the Cisco, and we may carry the maximum packet rate, and it's allocated the surface rate and the completion time. And the last one is the the flow level rate-based left banded category. It may the example is the N score, and it may carry the maximum packet rate and the allocated surface rate and finish time and the eligible time. So above is all the information we discussed with each queuing mechanism and carried the basic queuing metadata in the common format. So we will update the format or the metadata and follow up the process of the queuing solutions. The co-authors would like to know that if we need to define a common format to cover all the queuing solutions, or the working group may prefer that each queuing solution to define their each queuing metadata. So welcome their comments and suggestions. Thanks.
I just want to agree with your point that it would be good to see the queuing solution getting more mature for this, like whether or not we can have some common specification for the metadata. So I just agree with what you said. Any questions, comments? Yeah, please, go ahead.
Yeah, we also discussed this in PC session that we need to provide some common format or common data field encoding in control plane. So the PC chair also want to confirm that if we should adopt the PC extension after the DETNET have rough consensus, or we can adopt the PCAP extension first and then follow after the DETNET progress before the publication.
My personal view is that the DETNET working group should reach rough consensus first, because the PC working group does the work for the DETNET working group on this extent. So, but this is a coordination we can discuss further offline. But I think still the queuing solutions should become a bit more mature. We just started the work in the working group via the adoption, and then we can think about how to progress this work. And then if we have the rough consensus, we can reach out to PC working group. That's my view.
Okay, thank you.
Thank you. Any further comments on this one, or we can move to the next one actually?
Hello, this is open from CD. So this presentation is about the DETNET enhanced display interpolation, some considerations. Firstly, let's see what happened in the TSN solutions interpolation. In this case, the interpolation is based on two parts. One is the common fields such as polarity, and the second part is the log state maintained on each node. So see the following figure. There are two bridges interconnected with different TSN mechanism. In bridge 1, it configure a local stream feed policy that we map any stream with priority 3 to apply a gate control instance. In this instance, it will set IPv7 or IPv6, and the packet will be stored in the IPv related queue. That queue is enabled the CKF mechanism for scheduling. Similarly, on bridge 2, it will also configure a local stream policy, feed policy, and it will map any stream that with some specific DMARC, SMARC will ID, and priority 3 to apply the stream gate instance and set IPv7. And the packet is stored in the IPv related queue, and that is enabled ATS. So following the similar principle, ETP solution interpolation can also be based on two parts. The first is common metadata, such as latency derivation E, and the second is differentiated metadata, such as yes, that is related with specific ETP solutions. There may be, for example, maybe time slot or cycle or some finish time, and so on. So these are minor questions. DHCP can act as a common metadata. I don't think it is necessary for all ADP solutions. For example, some specific metadata of individual solution don't use DHCP for the packet mapping or scheduling. So see the following figure, there are 3 ETP domains interconnected with different mechanisms. The different metadata is used to guarantee the delay bound of the path of each domain. However, there may be some remaining jitter caused by the mechanism. So this latest deviation can be carried in the packet. It is termed as common metadata to remove this jitter and entry node of the next domain. So the end-to-end path across multiple EDP domains can use multiple binding seed. Binding seed is used to represent subpaths of each domain. The end-to-end path is represented by multiple binding seeds such as binding seed 1, 2, 3, and so on. The head end of end-to-end path only encode the metadata of the first domain. And when the packet arrived at the entry node of the next domain, all encodings added by the first domain are removed. Then it will dumping by the received common metadata. Then the encode the new metadata according to the new, for example, ETP2 mechanism. Note that the common metadata should be recognized by all ETP solutions. Instead, if we use a plain seed list to present the end-to-end path and encode all metadata of all ETP domains simultaneously in the packet, that is too long, complex, and unnecessary. So we have a basic conclusion that is the common metadata in ETP or the common fields in TSN are the key role of the interpolation. So this is the IPv6 ETP interpolation encodings. Then we have IPv6 basic header and hop, routing header, and the DOH. The different metadata generally encoded in the hop or routing header, while the common metadata is generally encoded in the DOH. I will not go detailed in the forwarding process. Yes, this is the MPS ETP interpolation encodings. It is based on the MPS MA, and the binding seed is encoded in the bottom of the stack, and only the B seed of the first domain is extracted to contain the detailed lib stack. Yes, I will not go detailed also. So this is what the content. Any questions?
Gino, please go ahead.
Thank you, Xiaofu, for the nice presentation. I really like your idea about differentiating solutions based on the metadata. I actually thought the similar thing. But my problem about that idea is that I just found, just like Chuan just suggests, the current metadata of different solutions are just so different. I do not think there is any common metadata for throughout the whole solutions. Maybe some of the similar categories solution can have a similar metadata, such as C-score and S-score, and your EDF deadline-based forwarding. But other than this closed set of the solutions, the common metadata can be found very hardly. So yeah, that's my suggestion.
Thank you. I have a simple answer that is, I think the common metadata is necessary for all solutions, whether it's flow-based, or class-based, whether it's read-based, or time-based, because whatever the solution is, if for the interpolation, the downstream domain just care the delay result, the delay bundle guaranteed result of the upstream domain. So the remaining jitter, I give it the term is the latency deviation. So the latency deviation must contain in the packet.
I'm sorry to interrupt you, but the latency deviation or end-to-end latencies, some of the solutions do not use them as metadata at all.
Yes, I know that, but I think it is necessary for all solutions. Maybe we can discuss this in the various.
Okay. My final suggestion is that if you'd like to proceed with this draft, I recommend to narrow down the scope a little bit, because not every solution can be categorized or summarized as the metadata. So
okay, thank you.
Thank you. Balazs, please.
Yes, thank you very much for the presentation. Again, a question for clarification. So based on the document, my feeling is that for the enhanced data plane, you are proposing to restrict the scope for some specific data planes like MPLS and SRV6. So this is something that we should not consider for all the data planes we have defined so far, but only these two specifics. Is that statement correct? I have some sympathy with that because of the addition of additional information to the data plane. You need some possibilities, and maybe these are the two candidates. So was that your intention?
Thank you. Maybe I can't reply you in the mail list. The voice is I need small, so I can't respond in the mail list. Thank you.
Okay.
Okay, good. Let's take it for the discussions on the list and move on to the next one. Thank you.
Yeah, just one more comment on the previous. The comment about making sure the draft covers all of our data planes that I made earlier applies here also. It's a general comment. If you're doing something, you really need to support what the whole working group has already, the previous work of the working group. Can't forget about that. Thank you.
Okay, thank you. So this presentation is about the mechanism to control jitter caused by polysen. The main updates from version 1 to 2, mainly related with the cross domains. How about polysen jitter is removed? So again, this is the overview of the solution. Let's see the picture. The end-to-end delay requirement by the service flow equals to the path delay and the edge-to-edge policy delay budget. The budget further equals to the head-end policy delay that is a runtime time is variable plus to the endpoint damping delay. So the endpoint damping delay can be carved in the packet used for the holding time imposed on the endpoint of the path. Then the packet sent to the application destination. So the direct question is how to set the edge-to-edge policy delay budget. There may be two options. The first is it may reach the order of magnitude of service bus interval. For example, then the flow may have burst service interval 100 microseconds and contains 3 packets P1, P2, P3 per SBI. So an extreme case of non-conforming arrival pattern is that the P1, P2, P3 arrived back to back. So P3 has the largest policy delay, maybe 2 of 3 of the SBI. So that one can be used as the budget. Alternatively, it may be a very small value, even 0, based on the sampling or configuration. For example, if the application source control the flow rate to not really conforming to fully comply with the spec, then the budget may be 0. Anyway, smaller budget is better. So we can see this week how the policy jitter works. So when the application flow arrived at the head end, it firstly taken by the shipping function, also named as policy function. So the back-to-back packet may be staggered or distributed in the service bus interval. So some packets may get a large shipping delay, and other packets may get a small shipping delay. So the arrived pattern will be changed to shipped pattern. Then the shipped pattern will get a guaranteed bounded delay or jitter along the DETNET path. So when the packet arrived at the endpoint, the shipped pattern will recover to the arrived pattern again. That may be a non-conforming pattern. So the jitter caused by the policy is removed. So there is some considerations about the multi-domain. There are also 2 options to apply the policy jitter control. The option 1 is there are separate policy per domain. In this case, the policy jitter control at the entry node and the exit node of each domain independently. So it is just it is applicable to the case that the transit domains maintain the flow states. In this case, each domain will contribute a separate budget to the end-to-end delay. So the delay may be large. While option 2, you will take only single policy for all domains. In this case, the policy jitter control only at the ingress domain, the entrance node, and the exit node of the egress domain. So only a single budget contribute to the end-to-end delay. We can see these 2 figures in the above figure. The arrived pattern is changed to shipped pattern in domain 1. Then when the packet left from the exit node of domain 1, it will recover to the arrived pattern again. Then the arrived pattern will further change to the shaped pattern in domain 2. And at last, the flow will recover to the arrived pattern again and exceed the node of domain 2. While in the figure below, the arrived pattern is changed to the shaped pattern. The shaped pattern will get a bounded delay along the end-to-end path that across multiple domains and the egress domain of and the exit node of the egress domain, the shaped pattern recovered to the arrived pattern. So that is the encoding of metadata. There's some considerations for how to calculate the damping delay, endpoint damping delay in the packet. So it may be calculated in the IPv6 DOH, or it may calculate in the MPS MA header. This solution has presented an IETF 121 meeting, and there is a concern about the difference between this proposal and the EDN. We have sent a clarification to the mail list. In brief, the different sense. This proposal is used to avoid jitter caused by policing delay, while ADN is used to avoid the jitter of path delay. So we can refer to page 3 for the relationship between policing delay and path delay. Questions and comments?
Gino, please.
Thank you, Xiaopu, and sorry for another comment. Could you go back to the maybe page 8, or I cannot remember it, maybe page 6?
Can you repeat?
Can you go back to page 6, maybe?
Page 6. Sorry.
Yeah.
Okay.
So the difference between the path delay and shaping delay, that's the main difference you mentioned about this, the difference of this draft and the ADN draft, right? But I cannot see any difference between the path delay and shaping delay in this diagram. So H means head, E means egress, I think. Then the domain 1 is a network of nodes, right? So there is a delay between H1 and HE1, or there are delays between H2 and E2. These are just ordinary network delay, right? Even if it is based on the path or queuing or shaping, they are all delayed the same. So I still cannot find any difference between two drafts. And more than that, yeah, I'll come back to that later. Please, please answer.
Yeah. Okay. Some good questions. I think the difference still exists because if the arrived pattern does not take the policing function, it will cannot get the delay bound. It will for any solutions, I think. That is, I think, is the requirement of the DETNET architecture document. Explicit the policing function is.
Yeah, but my point is that whether it is based on the delay is from queuing or policing or whatever, that ADN draft covers all kind of delay, and it can guarantee even zero jitter if you look into the ADN draft. So I still concerned about it. Okay, we can go offline. Thank you.
Okay, thank you.
Yeah, we are out of time on this slot, but thank you for the discussion. Since the two of you are there in person, maybe you can take advantage of being together and talk through where there might be similarities, and you can look to combine the work if possible. If they really have overlap, then it might be good to bring them together. There are some terminology things I'm also not sure of in this draft, but that's okay. We'll see how the work progresses. So thank you so much, and let's move to the next presentation. I think this one is remote.
Thank you very much. So this is a presentation about the draft, which is dealing with using SRv6 as a data plane for DETNET networks. Because it is dealing with SRv6, there is also a related Spring Workgroup document draft, which is describing the redundancy protection. And the DETNET data plane draft is describing how to use those seeds and the characteristics defined in the redundancy protection for DETNET data plane. This slide is just showing the update on the draft. The scope is to leverage the existing IPv6 encapsulation using DETNET specific seeds. In this case, this is the redundancy seed, how it is called in the Spring Workgroup draft. And the draft also optionally allows to use the traffic engineering mechanisms that are provided by the SRv6. The technical content of the draft is pretty stable. The only changes that we have made for version 2, which is the current version, some editorial changes, and there was also a terminology update to be fully in line with the Spring Workgroup document draft. So we are using also the term redundancy seed, and we are also providing the reference to the Spring Workgroup draft, which is, by the way, will be discussed tomorrow in the Spring Workgroup, and we will ask for Workgroup last call for that document. So that was the update on the draft. The content is pretty stable. It is fully in line with the Spring Workgroup work, and we think that it is the right time to ask for Workgroup adoption to deal with that in the Workgroup as a further step. That's it in a nutshell.
Okay, thank you so much. We do think it's important to coordinate anything we do here with the Spring Working Group, and we have not discussed this with them. But that said, we would like to run a poll here. We're going to ask two questions. They were on the slides. You saw them before. The first one is just really about the topic. Is there interest in the working group to work on the topic? So please take a look at the poll and respond, whether you're in the room or remote. Janu, are you in queue for this one or for the previous one?
Yeah, this presentation for this presentation. If
okay.
allowed,
so
yeah.
let me move on to the next question while you ask your question, because we can run the polls in parallel. So for just closing out the previous question, we are getting very reasonable participation of those in the room, and they're almost completely positive. They are interested in working on the topic. I'm going to start the next question, which is this document a good foundation for the work? And if we agree, that'll lead to an adoption poll, assuming the the Spring chairs don't have objection. So Janu, while we're running this poll.
Thank you. Yeah, it is not the question, just my comment or the impression. I'm okay with draft, except one thing, the title. I mean, I think the data plane, the term data plane is a little bit too wide, because this draft is about the replication and elimination. But we use the term in this working group, data plane, for some other meaning, right? The queuing, scheduling, kind of even lower layer of the data plane. But this draft seems to cover both of them. I'm okay with that, but some of the reader may confused. That's my only concern here.
Yeah, we've used the term enhanced data plane as a sort of euphemism for the queuing part. And we've been earlier in the working group, data plane was used to describe the formats used to identify the DETNET flows. So it is definitely overloaded usage, but I wouldn't blame that on Balazs. He's sort of inheriting it from the working group past.
Okay.
Now that said, Balazs, if you want to add to that.
Yeah, okay, thank you.
I think this is definitely something that we can discuss during the workgroup work. Maybe we can extend to add that, because this is not changing what we have already defined for IPv6 data plane. And maybe it would be worth to add some references to further format work done before, that we are not changing that. But what we are just adding here is the support for the redundancy functionality and using the redundancy seed. Yeah, I think this is something that we can add as clarification during the further work on this draft. Yeah.
Okay, this okay. Thank you.
Okay, I'm going to close the poll and then Xiaofu have a moment. It looks like we have some pretty good support. There are a couple of no's. If you've said no and want to briefly state your objection, I'd be definitely interested in hearing about that. Xiaofu?
Just what about the in native IPv6 case, how to encode in, for example, the flow identification and the sequence number information, because this document focuses on the SRv6. So what about the native IPv6 case?
For me, it was hard to follow. It was very low, the volume. But if I understand it correctly, you have referred to flow identification, and some information on that should be added to the draft, if I understand it correctly. But maybe let's move it to the list.
But the comment I heard was, what about non-SR IPv6? And I think the scope of this draft is just for SR. So just make sure the scope is clear. I think that was the comment. Of course, Xiaofu's in the room, so he can clarify. But we should wrap up. We have a moment if Xiaofu wants to say anything.
Yes, my question is about for the native IPv6 case, how to encode the flow identification and the sequence number, not just only for the SRv6.
Okay, thank you.
Torlis, I think you'll get the last say on this topic.
Yeah, I mean, I'm not sure the draft covers the full scope of what we could do with SRv6, right? So that's a little bit the problem that I would certainly think for all the advanced forwarding mechanisms, that SRv6 is certainly almost a requirement if we go for IPv6 as opposed to MPLS, so that we have it hop by hop stateless. And so I think that's the main challenge, that we make sure that we capture the topic comprehensively and not only for a subset of functionality.
Okay, so far, all the other SRv6 functionalities are assumed to be optional to be used. So you have your choice whether you would like to use it or you would like to use other, like traffic engineering, like path steering and stuff like that. But good comment, thank you.
Okay, thank you very much for the presentation. Thank you, working group, for the polls. The chairs will go and talk to the spring chairs by email, and expect to see an adoption poll on this. If we do run into an issue coordinating with the spring chairs, we will certainly let the working group know. And now for our last presenter, Carlos.
Yeah, this is Carlos Bernardos presenting on behalf of my co-authors. I'm going to try to be brief to leave time for discussion at the end. So just a quick recap, because this has been presented, or the previous reincarnation of this has been presented in past meetings. The motivation is that we have real use cases that involve or require multi-domain, and we have a first, well, we had some drafts in the past documenting some potential solutions as examples, and then we were kind of motivated or encouraged by the chairs and the working group to work on a framework for multi-domain. We did present one in last IETF in Montreal, but that was a PC-based framework, and we were also asked to kind of generalize that. So this is what we have done. Now this draft aims to be technology agnostic control plane framework for multi-domain. So we are just using the PC as an illustrative example, but any controller plane technology satisfying the requirements should be or could be used. So quick kind of a summary of the changes. So in the previous version, the one that was presented in IETF 124 in Montreal, we were using PC specific language. We were assuming that a domain had a mapping with a PC control domain. And we were kind of naming procedures based on PCE, the hierarchical PCE and the recursive PCE mechanisms. And also another change that we have done in addition to make everything agnostic is we have added a explicit functional requirement section in the new version of the draft. So one key question that we should address here in if we decide, the working group decides to work on multi-domain, is defining what we understand as a domain. A domain may be defined in different ways. We, in this draft, assume that the domain represents a collection of network resources managed as a single entity for path computation and resource allocation, etc. And we take a controller-based kind of domain. So domains are controlled by a single domain controller instance. So this is the primary definition, although we acknowledge in the document that there may be other definitions, like a pure administrative domain definition. So all the nodes that are under the same administrative entity, which is a common definition of domain. But also sometimes you can find a technological domain, meaning that a domain is characterized by sharing the same data plane technology. But that doesn't inherently define a control boundary, and that's why we basically propose to have this control domain based definition of domain. This is an example of a potential scenario where we have three domains. I will not go into the details. You have one that is wireless, a couple of them that are wired. We have nodes there, and we have also end systems at the end that, as we will see later, may be DETNET aware or DETNET unaware. And here in this scenario, you may have hierarchical approaches or stitch approaches, as we will see. Sorry, very quickly, we consider two coordination models for the multi-domain control, an hierarchical model, and also a peer-to-peer stitching model. I think we don't need to go into the details. It has been already presented in the past with a PC-based approach, but the assumptions are the same. And then we also added this new section on functional requirements for the control plane framework. So we assume that there is an intra-domain QS budget allocation. So each domain controller must compute the path segment meeting the specified share of the end-to-end latency jitter loss budget. We also assume that there is a functionality on capability advertisement. So the domain controllers advertise the structured traceability and availability budgets. And well, I will not go into, again, all the details for the sake of timing, but there are some functional requirements listed in the document for the functional control framework. We also list some multi-domain flow considerations on end-to-end path computation and system awareness, resource management, and potential flow aggregation. And again, I will just directly go to the next steps and questions, so we have time for that. So we try to do this exercise of generalizing based on the feedback that we got, and also adding the functional requirements section. We think that domain definition is a key point to address in any case if we want to do in the working group multi-domain work of any kind. And the questions will be if you believe as a working group that is interested in working on this and potentially adopting this as a starting point. Back to the chairs. Thanks. Well, Torles, I guess you have a question or comment.
Yeah, thanks a lot. I haven't had the time to catch up with all this work, but I think we had a great conversation in Montreal, and then of course also with the joint meeting afterwards. So I think I'd love to see, you know, just a minimum possible RFC kind of, you know, to promote the idea of interdomain DETNET, just, you know, something you can do on edge routers between domains, like from between a TSN industrial environment and a service provider, even pointing to the fact what you know, Telefonica was thinking of. Okay, we may not have full DETNET in the service provider network, but we have so much over provisioning, right? So the really practical entry point into DETNET on these edge routers. With then the question is, what are the minimum things we need to deliver on them? But also as a way to get DETNET promoted where there is no competition right now, because when we go into any of the other places, TSN is already there, and the whole large scale things we're just already working out right now, right? So, but the place where you already are experimenting and can put it in, I would love to see the smallest document we can do to get that promoted, even if obviously just informational. I think that would help a lot. And then all these technical details that tag along from it, yeah, I haven't found the time.
Yeah, thanks. Thanks for the feedback, and definitely we can do that. We are actually involved with Telefonica in a project that is going to start in May doing this.
Carlos, sorry to interrupt. I just want to let the room know we've started the poll. So please join the you know, and respond, provide your opinion. Would appreciate it. Carlos, back to you.
Yeah, I was saying that we are about to start a new project that involves Telefonica among other industrial partners, Siemens and others, and we are going to actually develop technologies and showcase in a high TRL environment. So we can leverage on that and bring that also as a contribution, as Torles mentioned. So thanks.
Hello, thank you, Carlos. Just brief
Janu,
comments.
before you, I'm sorry, just before you start. So the first poll, are you interested in this topic? We've had similar level of support, similar level of participation, excuse me, and no objections. So that seems like some good support for working on the topic. I'm now going to move on to the second question about the document. And Janu, you can proceed. Thank you.
Thank you. Quick comment. As I just presented in my contribution about the taxonomy draft, the taxonomy draft is also considering the interoperability between the domains, even though it is about the technology domain, not the control domain. But anyhow, I figured that two important aspects within the control plane. One thing is the admission control, end-to-end admission control. I think it is not trivial. And the second thing is about the slot configuration, or how the cycle operates periodically, because every domain has its own slot length. And I think it is very hard to coordinate all those domain level slot coordination. That's my comment. Thank you.
Good points. We can work on those details. Thanks.
Well, looks like we have no more comments. The participation in the second poll seems to be similar numbers, but we are getting a couple of objections, a few objections. I'll remind the working group that when we adopt a document, it's the start, not the end of the process. I think we have sufficient support to move towards an adoption poll in the working group. I'll confirm this with János, and I look forward to hearing from both those people who support it and also those who have the technical objections and what those may be. And with that, we are actually out of time and right on time. Thank you all for participating and the good discussions. G and Carlos, thank you for representing us in the room and helping us run the session. Yves, thank you for the great note-taking and your support. And János, anything else you want to say?
No, I also want to thank everyone, as you explained in detail. Thanks, everyone, and see you at the next IETF.
See you soon. Thank you.
Thank you.